Technology brings us closer together, even when we're far apart. Google developer groups host meetup events for local technologists to connect, learn, and grow with others in their area.
The project I'm mostly proud of would be teaching Introduction to Programming to 7 girls in my hometown.
In the GDE, I used to attend various workshops, like it was on Firebase, Android, Cloud. Everyone is learning from someone else.
We started to meet twice a week for a long time, learning Google Cloud. Amazing experience.
After joining Accenture as a software engineer, I started to share my journey in Medium, podcasts, and talks at online bootcamps.
My talk inspired one of community members a lot, so I mentored him to start his latter path. And 1 year later, at the same conference, he was giving a talk at the same stage.
One member of our community moved from being a DJ at our event to a developer in the first leading bank in the country.
When we do events that impact a lot of people, we are bringing opportunity to our region. So a lot of investors, a lot of startups, they will start to see opportunities here.
Hello to the Athens community, and welcome to another online meetup. My name is Marty Kodou. I'm one of the co-organizers of this community chapter. I hope our event finds you well. Today, I have the pleasure to welcome our 3 key speakers, George, Konstantinos, and Akis. It's actually the team behind the project supported by the Google Developer Social Impact Fund. The project is about the access food quality using Raspberry Pi and TensorFlow Lite for people with loss of smell. And before I welcome on our virtual stage our speakers, just a quick reminder to all of you. Our event is live streaming on Facebook page, YouTube, and Twitch account. So in case you want to make a question regarding the talk, please leave a comment. George, Konstantinos, and Takis, welcome.
Hello, everyone. Hi, Maggie. Thank you. Thank you for this opportunity. We are going to present the prototype now.
We are more than happy to host your presentation, actually.
I want to thank all the guys. They did a great job, Konstantinos and Akis. We have a great small prototype. We're going to present it, and in the future, we're going to improve it more.
So, George, are you going to start the presentation first?
Sorry, I didn't hear.
Are you going to start the presentation? I will be, be the first one to present. Okay.
I'm going to say the details, and later Akis will tell us about the prototyping board, and then Konstantinos will tell us about the mobile application that he has developed for this prototype.
Great. We are eager to learn more about the project. So the stage is yours.
Okay, thank you. Okay, guys. Today we are going to present a solution for detecting food quality with Raspberry and TensorFlow. This project is funded by Google Social Impact Fund, and it was an effort that lasted the last 5 months now, with the help of the GDG community. And a lot of guys helped, like Akis Vlisidis, that he created the prototyping board, and Konstantinos Michelis created the application for this prototype, the mobile application. Also, George Kandilogiannakis and Dimitris Panagopoulos helped with bibliography. I will tell some details about this project and how I wanted to develop it. First of all, I am a pharmacist, so basically one day a friend of mine told me that he has loss of smell because he had a bike crash. So that made me think that we could start searching for a solution also for this problem, because I usually go inside and attend some Google meetings, and I hear a lot about computer vision and NLPs and sound manipulation and all the machine learning models that help us during every day. But I haven't heard of a solution like that. So of course, there are a lot of bibliography online, and if you Google it, you could see about the electronic noses that some people have created. But personally, I haven't found an open source solution for that. So I came in contact with Google and they have this social impact fund. And I told them that we are going to create a prototype that's going to help for people with impaired sense of smell. And we are going to have everything as open source, so the future developers can take it from here and improve it, and of course create their own prototypes. Why Raspberry? A lot of people asked me before, why did you use Raspberry and not some other solutions like Arduino or ESP32 and etc. So the truth is that I am really a beginner in this area. So I have knowledge about 5-6 months in the single board computer. So it was really easy for me to select Raspberry from the beginning because it has a graphic user interface. You can plug it directly at a monitor, and you can use a Python IDE and see the details on the screen. You can also use the terminal. And of course, the great thing about the Raspberry is that it has these 40 GPIO pins that you can use and send and receive signals. So basically, this was the top solution for me as a beginner, and it was really easy to use it, and don't mix a lot of things, a lot of difficult stuff at the already difficult to build a prototype. Another thought and choice that I had to make back then was what type of sensors we are going to use. So basically, if you Google around and to see about the air sensors, basically you will find solutions like these, the MOS, it's the metal oxide semiconductors, or you can see them as chemiresistors. So basically, these sensors are the detection it changes based on the sensing of the material they have. So if the sensor comes in contact with more gas, the electricity passes inside the sensor, so we have bigger voltage. And also these sensors were really cheap. So basically for this simple MQ2 sensor, we had to pay about I believe it's 3 or 4 euros, so it was really cheap. Another advantage of this for the beginning, not after 2-3 months was that for me, that I was a beginner, I could use it directly with a PCB, like the one that you see at the left of the screen. So this one was on top of the PCB and had directly the pins for the electric current, for the ground, and for the analog signal. So for me, it was really useful because I was a beginner and I could use it directly. Another thing that we had to use at this prototype was an analog to digital converter. So basically, this air sensor gives us an analog signal based on the flows inside the sensor. We have these sensors until 5 volts. So basically, we had to convert it to a digital signal because Raspberry can only understand the digital signal. So this one can convert 0 to 5 voltage into digital signals, like from 0 until 65,472 units raw input. Also, this one was really cheap. So about this one costs about $5, and the we have to bear in mind that we were on a tight budget, and of course we wanted to make a prototype that doesn't cost a lot of money. So this was a nice solution, and it was cheap, and we could use it. And the first prototype that I created, so I had to experiment from the beginning, was back in March, and there you can see the setup. At the left of the screen, you see the sensor on the top of the PCB. You see the cables. You see in the middle the logic to digital converter, which converts the 0 to 5 voltage to 0 to 3.3, because the Raspberry can handle only until 3.3 voltage. So basically, we had to use a logic converter for that. The prototype that we had to use, of course, were of no use if we could have only one sensor. So basically, we had to fix a prototype that had an array of sensors. And this was the first prototype that I created at the end of March. And I started to experiment a little bit with cheese. Yeah, the food that we were testing was cheese, because it was a food that spoils really fast, and we can take values from the prototype from day 1 or day 2, and of course we tested it only for 1 day, for the first hours and the last hours, and to see if we can if it is good or bad. But this prototype had a really bad thing. So it was, as you can see, it has a lot of cables, and of course, nothing was soldered. And if one just pulled out a sensor or just a cable came out of place, it wasn't working correctly. Also, I had problems with current, because other times I was watching values on screen, and the prototypes showed about, let's say, 2,500 raw input, and the other time you just plug it in the power and you were getting 1,000. So basically, it was a big problem. So I thought that it was time that I had to start to build something that was soldered on the top of a prototyping board. This also was an effort of mine. I just soldered everything on top, and this was a really good solution back in April for me as a beginner, because the inputs that I was getting was really stable. If you just plug it on power and unplug it, so it was stable to use it for the experiment. And also, if you just move it or throw it, and it doesn't, anything stays in place, everything stays in place. So basically, it was good. So you can see at the right of the screen, I was starting getting some results, and getting these results in a CSV file to use it with machine learning. One of the bad things that this prototype had, so you see that every other week, I came up to a problem, so I had to solve it. Was that some sensors seems to be like dead, so they didn't give the signals were really stable, and I started to think that something was wrong with these sensors on PCBs. So looking at the diagrams of the sensor, I saw that, as you can see on the diagram, there is a resistor there that is for the sensing, and you can change it and you can increase it. And instead of the 10 kilo ohms that usually these PCBs with the sensors that the online stores sell, usually come with a 10 kilo ohm sensor. So basically we can increase it so we have bigger sensitivity. And so this was a nice opportunity for Akis to create this great prototyping board with sockets on top of this prototyping board. And if you can see at the right bottom of the screen, we can place the Raspberry directly on top of this prototyping board. And then we have the MCP now at the picture, you don't see it, but on this deep 16, you can place on top of the MCP 3008 to the analog to digital converter. And this one really gave a very good, it was a very good solution for our experiment. It was really stable, it was really accurate, it was really sensible. Akis used about the resistor he used was, I think, 22 kilo ohms, so it was really sensitive, and this helped me a lot to get really good values and use it with machine learning to get the TF Lite and use it inside there for the inference. Here you can see how we were saving the data. So every sensor, every 1 minute, we were getting the values from the sensors. As we said, these values were from 0 to 65,472 based on what the analog to digital converter can give. And we were collecting every value, so in every minute for 1 day. This is a typical diagram of 1 day, and you can see, so you can see the values from the beginning until the end of the day. I was splitting the data for the first values were just like it's a good food to consume it, and the last values were bad to consume it. So basically we were mixing them together, and we were building a simple machine learning model to help us categorize the food quality. The idea here is the machine learning model to help with the data and the prototype to help the machine learning. So combine these two things, we can get a very good result, and the and the accuracy was really high. It was more than 90%, and it was really a surprise. But you can see how a good prototype, a stable and accurate and sensitive prototype can help a very simple machine learning model with just one input, two intermediate layers, one output, and it just could get over 90% of accuracy. This is a diagram of the losses of the training and validation. And of course, we wanted to give a solution not only for the Raspberry, but we wanted to connect it with the mobile phone and have a very simple image on screen to say, hey, you can, the prototype says that this food is good, so you can consume it. Or the prototype says that this food is bad, so you don't have to consume it. And inside the prototype, because the Raspberry has very limited resources, we didn't want to install the whole TensorFlow library. So basically, the TensorFlow Lite team had something for us ready. It's called TensorFlow Lite, TF Lite Runtime. and we can install it. It's a few kilobytes, so it doesn't take too much space and doesn't take too much resources of the Raspberry to just do the inference. And the inference is done with a simple Python script. It just takes the values of the 8 sensors, it passes through the interpreter of the TF Lite runtime, and you get the result. The result there, it's passed to the mobile phone, and you see the result on screen. And of course, this is the output of the mobile phone. You can, it's good, the food is good quality, the food is bad quality. It was really a simple output just to help the user to see, and if some user doesn't know anything about raspberries. So, and right now I will pass it to Akis Vlisis, where he created the prototyping board, the super prototyping board, the super helpful, to tell us some things about this and how he created it and what was the advantages and disadvantages of the components that he used.
Hello, thank you, George. 2 months ago, Georgios contacted me and he described me the project, and he also showed me the prototype that he had. It was a bunch of cables. So I explained to George that basically I am a hobbyist in electronics. It is my hobby, and I had the last years I built many prototypes. I started with the cable mesh, like the first prototype of Yorgos, and I learned the hard way that it is very easy to move something, to display something, and especially in the what they call the power rail. If you make a mistake on the power, you risk to burn everything, to do a damage to your board, to not to the sensors. So I started building up this prototype that Yorgos showed. It is I use the technique of magnet wire. Basically, it is a small 0.1 millimeter wire that is isolated by Teflon or polyurethane, and by using very basic tools like a cheap soldering iron of 50 euros, and the board, this green board that is available everywhere for 5 euros maximum, you can build very neat and stable circuits. To the next step, of course, is to make a board, a production ready board, but we are not in this. It is not the focus of this project. It goes out of the hobbyist area. So it is I built this prototype by using very cheap and readily available tools, nothing fancy. So now let's talk something about electronics. Raspberry Pi. Raspberry Pi is a very delicate board. It is very easy to make damage, to do damage to this board, especially on the GPIOs. GPIOs, general purpose input-output. The ports that you connect anything to read or to write to. If you exceed 3.3 volts, you can find it on the Raspberry Pi site easily. It is very likely that you make a damage to the board. So you must be very careful on the maximum level of the input voltages. This is the reason that we use this level converter. It is probably I have, let's share screen. Okay. I will share my screen to show the the circuit diagram, schematic. This is the schematic of the board. This is the MCP 3008. It is an analog to digital converter plus a multiplexer. This is the ADC. It is one channel ADC, as all ADCs are. And this has in front a multiplexer that takes 8 analog inputs one by one. It switches from 0, 1, 2, 3, etc. Converts the analog value that it reads to a digital value and displays and outputs this value to a serial bus, and a SPI bus. All the modern electronics, they use now serial buses. They are very fast. They often exceed the parallel that we used the old days, the parallel bus. But this whole site is on 5 volts. So if we use directly, we connected this ADC to Raspberry Pi, we run the risk, it's 100% sure that we will make a damage to the Raspberry. So in between, we added a level converter that takes 5 volts from the high voltage side and converts it to 3.3 volts. So Raspberry Pi is safe. It has no risk to have any damage. On the analog side, basically what is? We have VHV plus is the internal resistor. All these MOS sensors have an internal resistor that heats up the sensor up to 150 degrees Celsius. This is the resistor that goes from 5 volt to ground. And between these pins, the sensor is basically a resistor, a variable resistor. So 5 volts goes to the sensor and after that to the ground. This makes a voltage divider. The output of this is directly related to the resistor that the sensor has, which is directly related, as you can see here, on the concentration of each of the gases. So, by reading one by one the sensors, we get the readings, and it is very, very reliable, much more reliable than having a wired prototype. On the board, on the first board, we added a voltage reference. Each ADC uses basically the ADC works like this. It counts from 0 to 10 bits, 4096. A reading is basically one number. What does this number represent? It represents how close is this voltage to the reference voltage. If this voltage is the same as the reference voltage, it gets the maximum reading, 4096. If it's 0, it takes 0. So, as you can guess, the stability of this voltage, it's very important. For example, let's assume that this voltage varies, but the resistor has the same value. This makes the output to vary without having any input variation. So that's the reason we use this voltage reference, to have a stable reference voltage. Basically, this is the circuit. It's very, very simple. 8 times the same circuit. We have to improve in the final prototype by reading the data sheets of the MQ sensors. In electronics, everybody should read the data sheet and only the data sheet. So, by reading the data sheet, it says that each sensor has a different, it performs, it has the best performance based on the RL, this is the load resistor. For MQ2 is 22K, for MQ3 is 22K, for example, MQ131 it goes to 1 megaohm because this sensor on the clean air, when it is in a clean air environment, the resistance that it has is around 1 megaohm. By dividing with a very small resistor, the dynamic range of the voltage is very small. What this means? It means that you have no great variation on the readings. The target is to split the whole range to the maximum values. That's basically what we'll do in the next step iteration of the board. It will be the same plus minor improvements. That's my part, I think, of the project. It is George?
Yeah, Akis, thank you very much. It was really nice and it was really helpful to use this prototype. It was really stable, accurate, and sensible, and I could get really good values. And now I'm going to pass the microphone to Konstantinos to tell us a little bit about the mobile application that he has created for this and what was the problems and trying to build the mobile application. And then I'm going to demonstrate a little bit the prototype. Okay, let's hear Konstantinos.
So, hello from me. Well, my part of the project was to make a connection to our smartphone, the remote device. We chose to use Bluetooth over Wi-Fi because we wanted to learn something new while creating this project. And I want to talk to you about the connection progress. So, what we want to do, we want to establish a connection so that our mobile devices would be listening to the data sent from the Raspberry Pi as it was making its readings and so on as a result. We want one device to be discovered from the other one. We chose that to be the Raspberry Pi as we wanted as little interaction with the Raspberry Pi as possible so that the user will just enable it and leave it there on top of the cheese, for example. And we wanted to have all the UI and the controlling through the Android device. So the Android device would be the one that would scan for nearby devices and find the Raspberry Pi and attempt to do a connection. The good thing about the Bluetooth is that if you have paired before, even once with one device, this data is kept on the phone. So in future connections, it's very easy to do that. The difficult part, except the fact that George was in another town from me and I had to experiment without being able to test my app, so I would do many prototypes myself and send them over to George, was the connection process. And that's what I'm going to talk to you about. So, the connection process. The difficult thing about connecting two devices using Bluetooth is that you have to understand how the Bluetooth API works. And that is not for Android specific, it's in general. So, the Bluetooth API works in the client-server-like architecture. That means that we have one device that works as a server and begins listening for connections in its Bluetooth sockets, and the other device must initiate a connection and become the client. This is very, very similar to what you see in a pairing process when you connect with your headphones, for example, with your phone. But the extra thing that separates a connection from a pairing process is that when you have a connection with a device, you can manually send data over through the socket that you have established with the device. The official documentation, which was very good, although there are very few projects that have found online open source that dealt with Bluetooth, says that in order to have two connected devices, you must have a Bluetooth socket on the same RF channel. So in the same channel, two devices must interact. How this interaction is made? Well, the client specifies a UUID, a universal identification, which must be unique, although for low-end hardware devices such as the Raspberry Pi, this is hard-coded and we could not change it. But if we would create a project for Bluetooth between two Android devices, it is recommended to create one unique such key, which is 128 bits. So it's very difficult to be found as well. And using this key, you create a connection, secure or unsecure, whatever you want, between the two devices. So the process is we make the Raspberry Pi discoverable, we initiate a connection, which is similar to the pairing process. I will show you later in IBATs. And then you can have these two devices connected. One, in our case, active at the server. So the phone was active at the listening part, so was just listening for data. And the Raspberry Pi would continuously send data through the channel, which is an easy implementation. So we had a very simple prototype. Let me show you a bit of demonstration. You could use a Bluetooth module connected to your Raspberry Pi to make it discoverable. And then we had a simple UI that would just scan for devices, and you choose the device, and then you select it and you start the channel. In this part, you send the data, and you say that I want to initiate a connection with the Raspberry Pi. This would pop up a similar screen with this, pair the device. If it was already paired, then you can start right away. And then comes the part where the mobile would start listening for data, and depending on what the Raspberry would send, if the food was good or bad, you had the appropriate screen displayed. A very simple prototype using the Bluetooth API. It was a nice experience for me to learn something new. I had some issues in the beginning because we were remote with George, and the whole process was not as easy to test as I thought. But I learned many things from this. The most significant things I've learned was about the permissions and how to use the API. So I made 2 million posts if anyone would like to know more about this. And of course, every other question you can reach me from here. So that was also from me. Thank you very much for the time.
Did a great job. The mobile application was, of course, very essential for our prototype. And now, Maggie, the moment of truth. We are going to demonstrate it. So we talked about it a lot, and we have to show it to the user. So, so to see that it's something that we have, it's not something in our imagination. So basically, I'm gonna make this laptop and to show you a little bit. First of all, I want to show you the first prototype that I had created. This was really, I don't know if you can see it. Yeah, it was a nice experience. It was nice for the start, and I explained that the problems I had with the cables and the PCBs and the sensitivity and the raw values. So it was a nice thing that I had to move, and the problems made me to move to the other, which I created just soldering these also the sensors on top of the prototype board. This was really nice, gave me really good values, but of course I saw that we had to change the RL of the sensor, so we have more sensitivity, and then IKES created this great prototype. So I'm going to just slide it a little bit to show you and do a little bit the experiment. So what we have been doing the past 4 months. So basically, this is the prototype. You see the Raspberry, and inside the Raspberry, it's at the top of the board. We have the cables for the mouse and the keyboard, etc., and for the power and the screen. And on the other side, we have the sensors. The good thing about this prototype was that for the sensor sockets, we can just remove one and put another one for our toys. So this is really good because you don't solder the sensors on top, and you can change the experiment, and you can do a lot of experiments with a lot of different food. And yeah, so basically now I'm going to show you and demonstrate a little bit this one. So as I told you, we were experimenting with cheese. One of the most important things was to just standardize the experiment. Of course, we had to have some specific containers and some specific amount of cheese inside. It was really easy just to have and to use the prototype and to have stable results and not make a lot of variables inside the equation and do it easily. So basically, as we said, we had good food and bad food. So first of all, I'm going to, let's say, whatever, I'm going to make it like a bad one, just put it on top. So basically, the idea is that we have when you put it on top of something, the sensors start sensing, and the sensitivity changes. So basically, they start taking some values. And of course, we have this. Yeah, I have to turn off the phone. So basically, we put it on top of this container. I believe, yeah, you can see it. And we just the prototype is just starting collecting the values of the specific, and you have on screen the X. So it says don't use the specific. If we change it with another one that is good, I just taken it from the refrigerator. Of course, sometimes, yeah, you don't get the values too quickly. So basically, you have to wait about 5 to 10 seconds because, but I believe this is a very good time. We don't have to wait just like 1, 2 minutes. So 5 to 10 seconds, I believe it's a fair time. Some prototype to wait, so we have the values on screen and result. If we test it again, we see the result, and then if we just take it to the old one, the sensors start collecting again the values. So we have to wait about 5 seconds. I believe it starts getting the and we have the raw values on screen. So we had a great experience. I have learned a lot of things. Also, the guys did an amazing job. Of course, we can make some improvements to that. We don't say that this is something that it's a high end and you can use it directly. We have to experiment with different RL resistors. We have to experiment with different sensors. We have other sensors that right now this. So I want to tell you also that this setup, except from the Raspberry, the setup costs about, I believe it's about 30 to 40 euros. So I believe it's a fair price. It's not something too high for what it can give us and the result it can give us. Another thing is the size of the prototype. So basically, we have now from about this size from 9 to 15 shrink it somewhere in the middle. So it will be 9 by 10. And or else we can use also an external source of power and not rely on the power of the Raspberry that has about 3 amperes right now from the power unit.
This is very
Experiment also
Georgios,
with.
this is very important. The power part is very, very, very important. By looking the data sheet, the schematic of Raspberry, you see that it passes the power through directly from the USB port to the 5.3 volt. On Raspberry Pi 4, which is USB Type-C, it is okay because it's a very powerful bus. But for cheap USB adapters, you can, if you stress enough the power rail, I mean, by putting a lot of sensors, you lower the voltage. That means you can cause resets on the board. It's very important.
Yeah,
Sorry.
Yeah, no problem. Thank you, Akis. Yeah, I just wanted to say about what we are thinking for the future. Of course, it's something that is really in the beginning. We are going to work with it in the next 1 or 2 years. We will have everything open source, and the future developers can benefit from that. Thank you again, guys. You did an amazing job, and I hope to collaborate in the future.
George, Konstantinos and Takis, many thanks for the presentation. I'm pretty sure that everyone enjoyed it, and actually, it's really nice to learn more about an open source project with an impact on our community. And we also have a few questions for you. So I'm going to start with the questions from our audience, which are: how does the sensor work to understand if a food went bad?
Okay, yeah. So basically, this is done through machine learning. We just collect the values from the prototype. We are creating the CSV file, and then we process it with machine learning. So by doing this job with machine learning, at the end we have inference result that the food is good, the food is bad. But first of all, we have created the dataset, and we have said that these values are good because the food now it's right from the refrigerator, and after some hours we say that from that hour and then the food is bad, don't consume it. So basically the data set says 0 for good, 1 for bad. So machine learning can then do this process and the result.
So, as actually we seen, you mentioned that you tested the MVP on cheese. Can we use the same equipment for other food ingredients, or we have to make modifications?
Yeah, sure. We can use it. We have a prototype that we can change the sensors and put different sensors. We can alter the Python scripts. We can experiment with different RL resistors, and we can use it for different food. Yeah. So, but we have to create a new data set for the specific food. This one is for the specific cheese.
And is it possible to check multiple types of food at the same time?
Yes, I believe this can be done also through machine learning. The most important is a good prototype, and of course to get a lot of results for the dataset. If you have a big dataset with a lot of types of food, then you can process it with machine learning. The power of machine learning is really high, is really good.
And last question, is the device online to use TensorFlow or it uses an offline mode?
No, the idea is to use it offline. So basically, we have created the TensorFlow model. We converted it to TensorFlow Lite, and this is used inside Raspberry with TensorFlow Lite runtime. And so everything is offline.
Great. That's all the questions I actually have from our audience. Konstantinos, Georgios, did you want something to add?
Just a little thing. From what we've read from online, from articles from our universities, that made some similar prototypes. Regarding your question about the food, there are some specific type of emissions from food that goes rotten, and most people just experiment on milk or cheese or meat, which is a very easy way to see for yourself it is rotten or not. So, for example, one type of food that has a mixture of other things, pasta, cheese, etc., would want a specific type of data set trained specifically for this. There is not a universal solution for everything, but there are some indicators for some foods that go rotten that are the same. We experimented with one type of food, but we could change that with similar or other sensors and train your data set accordingly.
Last but not least, my question actually, it's a personal question to all of you. I would like to know how you actually felt working together with strangers on a totally new project. I mean, how was the overall feeling working with someone that you never met in the past on a community project? So, George, do you want to start first?
Yeah, sure. I believe the guys showed that they want the thing that I want. So to pass the all the knowledge to the other developers. So basically, this is something that helped us collaborate. So the idea is to even if we are away and I'm in Kalamata and the other guys are in Athens and maybe they haven't seen each other from close. The idea is to everyone help each other and help the developer community and improve this area.
Okay,
Akis?
Personally, I enjoyed the project a lot. It's the first time that I work with somebody that I don't know. I never met with Georgios, and it's refreshing. I can say that.
Konstantinos?
Yes, I was also excited when I first saw that George was building something and he wanted a team. I said, why not? Let's help. It would be open source. I'm gonna learn something new. And the whole experience that, okay, let's build this. How we would do it? We would do it. Okay, let's try Wi-Fi, Bluetooth, and how would we send the data? All this experience and all these questions made me a better person, better team member, working with strangers and people with different backgrounds is very interesting, and I believe for everyone a process that gives you many soft skills that you would never get them elsewhere.
That's great. I have the feeling that you encourage more and more people actually to work together on community projects, and it's something very positive. So once again, Konstantinos, George, and Takis, I'm more than thankful that you joined us today. It was a great presentation so far, and we would be more than happy to host another event with not your MVP but a alpha version of the project. For the rest of our community, stay tuned for updates on our social media, gdg.community.dev and meetup channel. That's all, folks, for today. At least until our next online meetup. So bye bye, GDG Athens community, and bye bye, Konstantinos, Aikis, and George. Enjoy the rest of the
Bye.
day.
Thank you,
Bye.
Maggie. Bye bye.
Thank you, Maggie.